Hi, I'm Pranavi and my project is the KBIT-2 Rapid Score. The KBIT-2 Rapid Score was inspired by my work as a research assistant at the Kid Neuro Lab, where I help process behavioral assessment data from tests like the KBIT-2. So scoring the KBIT-2 involves just taking 5 input values here and manually searching through a dense book of tables, like the one here, to find over 20 additional scores, as you can see in yellow. It's slow, repetitive, and error-prone, and in many cases, only a few of these yellow values are actually needed. So I set out to automate this process. These tables come from a printed booklet, as you can see here. So I started by scanning the relevant pages and converting the PDF into individual PNG images using a function I wrote. The main challenge was turning those tables into clean, structured data. And so the core of my work focused on image processing and optical character recognition, OCR, and using OpenCV here and Tesseract. So here's an example of the raw OCR output. It doesn't even recognize that there are 3 separate tables here, and it treats them as one large block and introduces a lot of extra symbols. So to solve this, I broke the problem into modular imaging processing steps. So I developed an algorithm in OpenCV to detect the 9 vertical lines that divide the 3 tables on each page. You can see this in a debug visualization tool I built to confirm that lines were actually correctly recognized. So using a kernel-based method, I identified these vertical structures and then also calculated their pixel positions. And so the algorithm actually is fully adaptable across the pages, and so it just adjusts to variations in scan alignment and table spacing. And based on that, I was able to split the table into 3 new table segments, and then I reran OCR on the cleaned outputs. You can see that here, and you can see that the accuracy improved significantly. And so from there, I built a data validation pipeline to clean and verify the results. So I started by removing extraneous characters like the ones you can see here. And one of the things I also noticed is that oftentimes if there are 3 values, they're missing the first column, which is the raw score, and you can also see that down here. So I implemented a backfilling mechanism to recover these missing raw scores. Basically, it tracks the last known valid raw score, or that was updated, and then it infers the values based on the other information in previous rows. And so this ensured consistency even when the OCR output was partially corrupted. So I was actually able to transform the noisy OCR outputs into clean structured CSV files for this, and they were ready for downstream analysis with just some manual tweaks for some edge cases. So that was the backbone and the heart of the KBIT-2 Rapid Score interface I built. It lets researchers upload their data with those 5 critical values and instantly download their results. So I'm currently working on connecting the front-end data to the back-end to complete the full UI. Okay, so this is the user interface for my project KBIT-2 Rapid Score. When users first arrive on the template screen, they're given the option to download a template file. So this template includes all the required fields, like participant ID, age, and raw scores, so the users know exactly what input is needed. It helps standardize the format and makes the rest of the process seamless. In this example, I've already included a filled out data file. It just contains basic information and raw scores. Everything else will be automatically generated. So we can go ahead and select the example data file. Next, we can select which output categories we want to include. We'll just select all. And once that's done, we can download the final results. Here's what the final CSV looks like. You'll see both the original output and all the additional scoring information filled in, pulled directly from the standardized scoring tables.